Hi friends, this is Shomik Bishwash. My today's topic of discussion is Fourier transform. So, Fourier transform. So, what is Fourier transform? First of all, we have to know Fourier transformation is a particular mathematical tool which will convert that any signal from time domain to complex frequency domain. Okay, so what is the basic case of the Fourier transformation? So actually Jean-Baptiste Joseph Fourier, that Fourier named on whom, has derived one particular formula to analyzing the non-sinusoidal waveform from the other different sectors of the engineering problems area. Later on it is applicable in all of the circuit theory and communication engineering in a wide way. Now, what is Fourier transformation then? So, any signal which is periodic but not a sinusoid or cosinusoid can be expressed as f of t if the original signal equals to a0 plus summation of n equals to 1 to infinity m n cos of n omega 0 t plus phi n. Okay, now if you are considering for n equals to 1, for n equals to 2 in this way, so as many number you will be getting as m1 cos omega 0 t plus phi 1, another you will be getting as m2 cos 2 omega 0 t plus phi 2, like this. So in this way, up to n is going to infinity, whatever function you will be getting, these are all called as a harmonics. So if you are writing these harmonics, all of them in a complex dimension, so what we will be getting as f of t equals to a0 plus integration or summation n equals to 1 infinity c of n into the power j omega n t. Okay, this is now this is called the Fourier coefficient for complex Fourier series. Okay, now what is the value of Cn? How we have to evaluate Cn? Cn equals to 1 by t integration 0 to t f of t e to the power minus j omega n t dt. This is the formula of deriving of Cn. Now that Cn is a complex number, can be expressed as, again, if it is taken as a real valued function, so we can again write that 2Cn equals to 2 by t 0 to t f of t e to the power j omega n t dt. Now it can be written as cos theta minus j sin theta, so that is 2 by t integration 0 to t f of t cos j omega n cos omega n t minus j sin omega n t or n omega t, whatever you can write, dt. So this is 2 by t integration 0 to t f of t cos of n omega t dt minus j into 2 by t integration 0 to t f of t sin of n omega t dt. Okay, so this particular part is called an, this particular part is called bn. Okay, so can write as 2cn equals to an minus j bn. Okay, that is one very important formula of conversion of Fourier series from one domain to another domain. Okay, where it is a 2cn, it is completely complex Fourier series, or e to the power j omega domain, but here it is cos and sine, so this is a complex form a plus j bit, and that is rational number cn. It is a coefficient of the exponent Fourier series like this. Okay, so one Fourier series can be represented as f of t equals to a0 plus summation of n equals to 1 to infinity an cos n omega t plus bn sin n omega t. Okay, where a0 equals to 1 by t integration 0 to t f of t dt. Okay, a1 equals to 2 by t integration 0 to t ft, it is right, an ft cos of n omega t dt. bn equals to 2 by t 0 to t integration f of t sin n omega t dt. Okay, so here you will be getting the three coefficient a0 an bn. Here you will be getting the coefficient cn. So these are the coefficients of the Fourier series. Now if you are taking the conversion between the Fourier series and the Fourier coefficients, so obviously the coefficients are this an bn a0 cn, these are the coefficients, but when you are writing the series you have to write it in this form. This is one form of the complex series, or this is a form of that exponent series, so you have to write any other form. This is called the Fourier series, but these all things are called the Fourier coefficients. Now we will discuss some property that the Fourier signals are of different type. Say this is one signal like this, say this is b, this is a, this is 0. So this function is called that even function. If this is ft, this is t, this is a even symmetry or the even function. Okay, now for that even function evaluation, if you are applying that Fourier transformation, you will be getting that some value for a0 and that value for an, which is 2 by t0 integration 0 to t f of t cos of n omega t dt, or a0 that is 1 by t 0 or t, whatever, you should write that 1 by t0 f of t dt. Okay. Now if the function like this, so for the same time period, that is v, that is 0, that is a, and that is ft, that is t, you can consider that is k, and that is also k. See, so for this case we are not getting these two, we will be getting only bn, that is equals to 2 by t0 integration of 0 to t f of t sin n omega t dt, only this. But one condition is what? Here the time period, what you are taking as a time period, the time period must be t equals to 2 pi, then only. Okay. Now here one case can be discussed, one more, that now, so as I am discussing that t equals to 2 pi. Now if t equals to 2 pi is not actually, it should be t equals to 2 pi by omega. So here the 2 pi case, that omega equals to 1, but here actually t equals to, this is the formula. So if t equals to 2 pi by omega, if you are considering this, so for that same even and the odd symmetry, we'll be having multiple by 2 case. So here that if it is even symmetry, then a0 equals to 2 by t0 integration of t1 by t1 plus t0 f of t dt, or simple you can write that 2 by t integration 0 to t ft dt. But an equals to, instead of 2, it is 4 by t integration 0 to t f of t cos of n omega t dt, or omega 0 t, some arbitrary values. So this is a basic function of a0 and an will be getting by this. So otherwise, if it is odd symmetry, so it should be 4 by t integration 0 to t f of t sin n omega t dt, some arbitrary in omega 0, okay, the base frequency. Okay. Now another part has come called half wave symmetry. What is half wave symmetry? Half wave symmetry is that one function, suppose it is like this, for 0 to say t0 by 2, again that is t0 for t0 by 2 t0, it just look like just reverse of that. So this is called the half wave symmetry. So what is the condition? That f of t equals to f of t minus t0 by 2. What is the relation? Inverse. So it is a minus. This is a half wave symmetry. In the case of half wave symmetry, we are considering that t equals to 2 pi by omega, the same. There only an and bn exist. a0 equals to 0. So obviously it is 4 by t integration 0 to t f of t cos of n omega 0 t dt, and it is 4 by t integration 0 to t f of t sin n omega 0 t dt. Okay, so this is in short that scenario by which you can take very easily the Fourier transformation and the Fourier coefficients. So what is the coefficients, what is the transformation? So if a non-sinusoidal waveform is transformed to Fourier transform by having that coefficients. Okay, so then if you are having the coefficient, you can write the Fourier expression. So you can write the Fourier expression in total. So in this way the non-sinusoidal wave can be converted to sinusoidal wave by the case of Fourier transformation. Here one thing I like to share, that what is the basic difference between Fourier and Laplace transformation. Actually in Fourier transformation we are considering that omega from minus infinity to plus infinity. Okay, so there this is plus j omega, this is minus j omega. Okay, so we are considering that here if it is Fourier transform of t equals to integration minus infinity to plus infinity f of t e to the power j omega t dt, like this. But if you are writing the Laplace transformation, so L of ft from right in this way, so it should be integration of 0 to infinity f of t e to the power st dt. Now as you know that s equals to sigma plus j omega. Okay, sigma plus j omega. So in this Fourier transformation we are taking all the complex frequency transfer portion, that particular j omega portion, complex frequency analysis of this ft. So this real value, that sigma, it is untouched. So if you are solving any RLC circuit, you can say that there will be an e to the power sigma. So this particular sigma caused one phase of that particular one. So this is the frequency part, this is the phase part. So the phase part is remain unchanged, just the frequency part. So there will be many harmonics. It is a conception of the Fourier transformation. So ft is used. But when the entire time domain is converting to that frequency domain, complex frequency domain, j omega domain, so that is a Laplace transformation. So Laplace transformation is considering that phase and frequency both of a signal, and it is taking to that again time domain back, after that inverse Laplace transformation. But that Fourier transformation obviously taking the analysis of that j omega plus n minus n. So it is creating basically the image frequency. So here one part, here another part. So it is that completely image. So if you are taking the conversion of sine of n omega t, if we are taking a Fourier transformation of that, so what will be the answer? That is, one is, if you are taking sine, so obviously it is written as e to the power j omega t minus e to the power minus j omega t. Okay, so if you are taking this, so obviously j omega and j omega, 2 j omega, so it should be something in Laplace, it should be something s, that is 1 by s plus j omega minus 1 by s plus j omega. But in here the Fourier transformation will show that in one case it is e to the power 2 j omega. So that if you are integrating e to the power 2 j omega t dt, it means 2 j omega t by t. We are integrating this particular function from 0 to infinity, it is basically showing 0, so 0 means 1, that is t. So it is no, sorry, it's 2j omega. I'm doing wrong. That is 2j omega. So 1 by 2j omega, and another is 0. Okay, so it will be getting one impulse only one impulse. So but in this case it should be divided into 2 image frequencies is here, so that modulation is done, multiplying this with that cos function or the sine function. So it will be creating omega t plus c. One should be omega minus omega c, one should be omega plus omega c. So these two things will be sending, and when you are sending only one, this is called a DSBC. You are telling the both, this is called the is a part of communication, so we don't go much further of this. So this is the basic of the Fourier transformation, as you can see, and whatever the conversion you should take place. So in the next classes of the Fourier transformation, we will do lot of mathematical problems on that we have a clear-cut concept and clear marks whenever the question being asked in any sort of semester examination. Thank you very much.